Hey guys, it's Mr. Lowry. I wanted to give you a couple helpful hints maybe here on this Unit 4 test review. When you're reviewing for this test, the first thing I would do is I would go back through your old notes and homework assignments. They should all be in your notebook organized. That's the whole reason why we keep a 3-ring binder, is so we can organize all our work. And that should be a really good place to help you get started. I will do a couple problems with you here just to help you if you're struggling on this one. First off, there was a typo here, so if you got this in class, then I think I probably asked you to change this to a -10 and a -19. If you downloaded this, then I should have already changed that for you, and it should already be changed for you. Let's go ahead and get started on this one, though. The directions say determine if the ordered pair is a solution for the system. Okay, so here's an ordered pair. It's like an x and a y. Right? And we want to determine if this is actually a solution. If it's a solution to the system, it will give us identities for both equations when we plug it in. So let's see if that works. Okay, so I'm going to rewrite the first equation, but everywhere I see an x, I'm going to replace it with a 3. So I got -3, and then I got 7 times -1 equals -10. Remember, when you replace a variable with a number, you always want to put it in parentheses. That's especially true for negatives, but it's a good practice to get into. So this is just a regular -3, and this now is going to be a -7. That should equal -10. Since these are both the same sign, they're actually working together in the same direction. So I combine the 3 and the 7 to get a 10. And they're both negative. I know it's going in the negative direction, so it's going to be a -10 equals -10, which is an identity. So this ordered pair is a solution for equation number 1. We have to make sure it's also a solution for equation number 2, though. So we need to plug these numbers into equation number 2 as well. So -6 times 3, right? Again in parentheses, just rewriting the second equation, plus y. So I'm going to put a -1 in parentheses, plus -1 equals -19. Okay, when I multiply through, this is going to be a -18. This right here will just be a -1. Again, they're both the same sign, so I'm going to combine the 18 and the 1 to get a 19. And since they're both negative, I know that this is going to be a -19. And I get another identity, which means that this is also a solution for this equation. Since it's a solution for both equations, we would say it's a solution for the system. Remember, a system is just more than one linear equation. So if it's a solution for equation 1 and it's a solution for equation 2, then it's a solution to the system. So I would say, yes, it is a solution to the system. 3 -1 is a solution to the system. Okay, so you're going to try number 2. Again, we're trying to verify if this x and y will give us an identity when plugged into both of those equations. Okay, let's take a look at number 3 here. If given a system of equations in slope-intercept form, how could you tell if the system had one solution, no solution, or infinitely many solutions? Okay, if you remember, we made this diagram, and you should probably go back and find it on your notes if you don't know the answer to this question. We made a diagram that showed all the different types of solutions or systems of equations, right? Remember that a solution between a system of linear equations is an intersection point. So sometimes you'll get an intersection point between two lines, but sometimes two lines will never intersect. And sometimes you'll have two lines that are really just like right on top of each other, and they actually intersect everywhere. Okay? So you can tell if the lines are going to intersect based on the equations. You can look at the equations and tell. Okay, let's talk about the parallel for a second, and then you can maybe kind of look at the other ones. Parallel lines, if you look at their equations, will have the same slope, right? So something like this. These two lines are going to be parallel because they have the same slope. So if two lines have the same slope but different y-intercepts, they're going to be parallel, which means there's going to be no solution. Okay? If two lines have different slopes, they're definitely going to intersect. And here what would happen is the equations would actually be exactly the same, right? So y equals, let's say, 1/2 x plus 2, and y equals 1/2 x plus 2. Okay? This one just has to have different slopes. Okay, so the idea here is that you can look at your equation. If they're in slope-intercept form, you can compare the slopes and the y-intercepts, and you can see if they're going to, if they're going to cross. If the slopes are different, I didn't give an example here, but just basically anything with different slopes, then your equations are going to cross, or your lines are going to cross. If the equations have the same slope but different y-intercepts, that means they're parallel lines and they won't cross. It means you're going to have no solution. Okay, and if it's the same exact equation, you have a line on top of another line and they intersect infinitely many times. Every single point on the line is an intersection. Okay, so you're going to have to put that in your own words. Explain means to write out in sentences, so you need to write out in sentences. Pick your own examples in your explanation. Don't use mine, use different ones, and talk about that idea. Okay, I want you to be able to understand what you're looking for and how you can tell if the equations are in slope-intercept form. Speaking of slope-intercept form, okay, here we go. We're going to solve these by graphing, and these are both in slope-intercept form. So just a super quick review of graphing. Hopefully you know this by now. If you don't know how to graph a linear equation, then we should probably talk, but this will give you kind of a refresher here. Okay, when your equation is in slope-intercept form, you start by finding the y-intercept. Remember, slope-intercept form is y equals mx plus b, where b is your y-intercept and m is your slope. Okay, m is the number multiplying x, the number in front of x. Okay, so in this case, my y-intercept, my b, is -1, means start down here at 0, -1. And then you don't see the slope, which means it has to be a 1, right? 1x. If it's just an x, it's just 1x. So I turn that into a fraction, which is 1 over 1. Okay, this is rise over run, right? Rise over run. So this is up 1 and right 1 from here. Up 1, right 1, up 1, right 1, up 1, right 1, up 1, right 1. You could also go backwards to get the rest of the points, right? Okay, there's line 1. Okay, line 2. Here's the y-intercept. Start at -4. Okay, here's the slope. Now, -1 over 2, that negative needs to go with the top, but or the bottom, but not both. Okay, now typically there's 3 ways to write this negative, and 2 of them are correct. This is fine. Whoops, sorry, I can't see that. -1 over 2 is fine. -1 over 2 with the negative out front is fine. And then this is actually equivalent. These are all the same thing, but this is not the way we write it. This is not simplified. Either of these are the way you're going to write it or the way you're going to see it written. So with this -1 over 2, the top is -1, the bottom is +2. That means down 1 and right 2. So from here, down 1, right 2. Okay, I ran out of room, so I'm going to have to go backwards. And you can see now that there's that intersection point. Okay, there's your solution, the intersection point, right? -2, -3. Your solution should be an ordered pair. Okay. Let's flip it over. Okay, in 6 and 7, you're going to need to graph them as well, but they're not in slope-intercept form. So you need to convert them to slope-intercept form, which again is y equals mx plus b. It's a really good skill to have to be able to put something in slope-intercept form because we use it so often. Okay, so let's start with equation 1. Slope-intercept form, notice, has y by itself. So we need to get y by itself. So the first thing I'm going to do, actually I'm going to do some work down here. The first thing I'm going to do for equation 1 is I'm going to start moving stuff away from the y's. I need to get y by itself. Okay, notice that -2 and -x are not like terms. So as much as we'd like to combine them, we can't. So -2 minus x is just -2 minus x. Can't really combine them. However, I can reorder them. So I can put the -x first and then the 2 after that. And that's actually how I want to write it, because in slope-intercept form, the x is the piece that comes after the equal sign. So I want the x piece after the equal sign. Okay, the last step is to divide both sides by 2. Now when you do that, you have to actually divide each piece individually. Since these are two separate terms, each one needs to get divided by 2. So it's almost like a distribution kind of thing. So you got 2y over 2, you got negative x over 2, and then you have negative 2 over 2. So both terms of that expression are going to get divided by 2. So here the 2's cancel, we get y, which is what we wanted. Okay, now remember, if you don't see a number in front of that x, then it's got to be a 1. Right? So this is negative 1x over 2, or negative 1/2 x if you want to write it like that. Okay? 2 over 2 is just 1, right? But since it's negative over a positive, it's going to be a negative 1. Okay, so now that's your equation in slope-intercept form. There's your intercept. There's your slope. Right? So I put an intercept at negative 1. So this is down 1, right 2. Okay, we can also go backwards the other way to get some more points. Okay, so there's our first line. All right, now we have to do the same thing for the other equation, so let's do that. Okay, 3x minus 4y equals negative 16. Again, I want it to look like this. So I have to start moving things away from y. Let's start by subtracting 3x from both sides. That means negative 4y is equal to negative 16 minus 3x. Now again, these are not like terms and I can't combine them. However, I can reorder them so that the x piece is the one that's coming after the equal sign, because that's how it looks up here. Okay, so this one has an x, this one doesn't, can't combine them. There we go. Next step is to divide both sides by negative 4. Now if we want to take kind of a shortcut, similar to what we did down here, we can just put every term individually over a negative 4. And that will kind of save us some time, because we ended up doing that, right? Over 2, over 2, over 2, but we had this extra step. Really, we're dividing both sides left and right by 2, but when we kind of distribute that divide by 2 thing, we end up getting the other ones. Okay, so over here, this is just a regular y, because the negative 4's cancel. Okay, over here I have 3 over 4, but the negatives cancel. Negative over negative is positive. So I get 3 over 4x. Now I have negative 16 over negative 4. The negatives cancel again, giving me a positive number. And 16 over 4, since 4 goes into both, is going to reduce to 4 over 1, or just 4. Okay? So this guy starts over here at 4. Okay? This is where it gets a little tricky, right? Because your next point is going to be, you're going to have to go up 3 and right 4, right? So you go up 3 to right 4, and you're like off the graph. So you have a couple options. If you want to just kind of like, eyeball it, you can, but that might not be very accurate. So if you're going to go up 3 and right 4, you can also go opposite of that and find another point by going backwards. So you could go down 3, right 4, or sorry, left 4, excuse me, down 3, left 4. All right, so again, normally this means up and right, okay, but I don't have any room to go up and right. My point's going to be over here. So instead, I'll just backtrack, and I'll find my point that's over here. Now from here, check this out, to double check. From here, if I go up 3, right 4, yeah, I get to another point. So when we do our graph, we do our slope, we usually go left to right. So when you get that point on there, just verify that you really are going up 3, right 4 from left to right, and then you should be good. And we found our intersection point, negative 4, 1. Okay, so on this one, you got one of them to solve, and then you're going to graph them both and find the solution. Okay, these I'm going to let you answer on your own, but we'll kind of address this as we go do some other problems. So 8 and 9, you're going to write what you think. You're going to explain your own thinking, because I kind of want to see what that is. But we'll talk about that in a second. Okay, 10, kind of same idea. We'll address that in just a second. I want you to think about it. Okay, now this here this is kind of where we're gonna talk about some stuff. So it says choose a method for solving the system and then solve. Write the method you're using, show your work in organized steps, box your solution. Our 3 methods are graphing, elimination, and substitution. Now if you want to solve these by graphing, you can. you're just going to have to include that graph in your work. And also, when you get to the test time, that might be kind of difficult. So I wouldn't recommend that. I wouldn't recommend using graphing on any of these, although it is possible to solve them by graphing. It's going to be difficult, and your graph's going to have to be really big sometimes and really detailed. And probably the best option for these is either elimination or substitution, which are our two algebraic methods, the algebra methods that we have. Okay, let's take a look at a couple of different problems here. Okay, let's start with number 12. If you notice that both of these are in standard form, it's kind of, a little bit more obvious what method we're going to use, because elimination is the method that combines the like terms down the columns, right? Combine the x's, combine the y's, combine the numbers. The goal is to get something to eliminate, and in this case, nothing's going to eliminate right off the bat. So I'm actually going to have to make it eliminate. To me, it looks like the easiest thing to do is to get this y to be a negative 15. And I can do that by multiplying by negative 3. Just like we talked about a few minutes ago, when we multiply both sides by negative 3, if there's more than one term, we're going to have to distribute. We talked about that with division, but it obviously works the same with multiplication. So my top equation becomes negative 21x minus 15y, which is what I wanted, equals negative 90. Okay, beneath that you have negative 3x plus 15y equals negative 30. And now we're actually going to get an elimination. So combine the like terms, combine the x's down the column here. This is going to be negative 24x. Okay, the negative 15 and the positive 15 go away, which is what we wanted. And then we get a negative 120 right here. Okay. Divide both sides by negative 24. So we need to do negative 120 there we go, divided by negative 24. So x is equal to 5. Okay, that's not our solution, that's just half of our solution. So we need to keep going. I'm going to draw an arrow to show where my work is going. So x is equal to 5. The next step is to find out what y is. We do that by taking this and substituting it into one of the equations. Doesn't matter which one, I just picked the top one. So this is going to be 35 plus 5y equals 30. Okay? If I subtract 35 from both sides, I'm going to get a 5y equals a negative 5. And then when I divide both sides by 5, it looks like y is equal to negative 1. So my final solution is y equals negative 1. Okay? Problems like that I typically do with substitution. You actually could solve it, with elimination. I typically do problems like that with elimination. There is a way to solve it with substitution, but it's a little bit more work than you need. Also keep in mind that some of these problems will have no solution. If you get a contradiction, for example, you're going to have no solution. They also might have infinitely many solutions, which happens when you get an identity statement. So if you need extra help with that, then go back to an assignment where we did some practice. It was called Solving Systems of Equations Practice, and we talked about when we got what do you do when you get no solutions and infinitely many solutions, what that looks like. All right, some of these other ones are set up a little bit differently. So let's look at some back here. Okay, 18. I could solve this with elimination. I would just have to rearrange it a little bit. I would have to make sure that the x came over here. Now, you could actually do that. So, for example, if I added 4x to both sides, that would give me 4x plus y equals negative 19. I can rearrange the equation, add 4x here, cancel it out, add 4x here, to get it in standard form. So you're not like totally locked in, because now this I can solve with elimination if I wanted to. However, typically you're going to use substitution when you see a variable by itself. It's less work to do substitution. because you'd have to like, change it, manipulate it. So you could solve this with elimination, but I wouldn't, well, you can do it if you want, but substitution is what I recommend and what I teach to do here. If you got a variable by itself, y equals, awesome. That means substitution to me. That means I'm going to replace y. So I like to write myself a little note, replace y. I'm going to replace it with this. I'm going to replace it right here, that y, in the second equation. So I'm going to rewrite the second equation. 2x plus 7y, but instead of y, I'm going to write negative 4x minus 19 equals 23, right? So 2x, 7, y, but instead of y, I wrote this stuff, right? I replaced it, and then 23. Okay, so 2x, distributing the 7, I get a negative 28x, and then 7 times negative 19 is a little too big for me. So I'm going to need some help there. So that's negative 133, and then that equals 23. Okay, combine the like terms here. So 2x and 28x is going to give me a negative 26x. Okay, I got a negative 133 equals 23. Okay, add 133 on both sides. Okay, and it looks like negative 26 is equal to $156. Oh, that's going to have an x in it. Negative 26x equals 156. So divide both sides by negative 26. Let's see what we get. Negative 6. Okay, now we're not done yet. We need to find out the other variable. So we're going to take this guy. We're going to plug it back in. Now you could actually plug it in either of these two, but I would recommend plugging it in the top one because y is already by itself, and that's what I want. I want y. So if I just take this negative 6 and put it there and combine these guys, I'm going to get the y value. Okay, I'll let you take care of that. All right. Now for the hard part, right? The part, actually, sorry, give me just a second. Let's go back and talk about some of these really quick. And then we'll talk about the word problems. Okay, if you go back to some of these questions, all right, you can kind of answer it yourself. We talked about, when to do what method. Now, actually, as it turns out, you can do either. If you wanted to use elimination on this guy, you would just have to manipulate it a little bit. You'd have to move it around, okay? And this guy, you could solve by substitution. You just have to get a variable by itself first, okay? As it is right now, I would say that this is probably one I would use substitution on, and this is one that I would use elimination on. So talk about that, talk about what you're seeing, explain what's going to happen, and then solve the system. Okay, just want to see your thinking, your words, your description on there. Okay. In this one, this actually looks like it's set up for elimination, and you could use elimination, but my question in this is actually, could you use substitution? How would you change it so that substitution would work if it was possible? Okay, so you're going to want to think about that, and like I said, this is typically one we would do elimination on, but is it possible to solve it with substitution? Okay, so think about that one. Okay, now to the word problems. Okay, these are a little tricky. I'm pretty sure that you guys can probably handle this one because that one's not too bad. They're just two pretty straightforward equations in standard form. You're going to have two equations though because you have two people, right? So you're going to have an equation for Stefan, and you're going to have an equation for Norikai. And you're basically going to have them in standard form. So what you're going to want to do is annotate. Let's use square for Stefan stuff, and let's use circle for Norikai stuff. All right, you want to go through and find those quantities, Stefan, 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 and write an equation that relates those quantities. Now remember, there's some unknowns, right? The unknowns is the cost of a French silk cheesecake and the cost of a chocolate marble cheesecake. So you could use variables like x and y to represent those costs. We don't know how much they cost. We only know how much of them we sold. Okay? So you're going to have an equation that has x, y, 10, 2, and 88 for Stefan. Okay? We also got some information for Norikai. We got this 5 silk cheesecakes, these 10 chocolate marbles, and these 125. So all those circled numbers will go in equation number 2 for Norikai. But you're still going to need x and y because, again, we don't know how much each one costs. Okay, so write out your equations for that one, and then you can go ahead and solve it from there. Okay. Just since we already have it labeled, I'll help you out with the setup. I'm hoping that you guys can set this up, but because we did a bunch of these in class. But just in case you're struggling, this is the setup for Stefan, right? He sold 10 French silk cheesecakes, but we don't know how much they cost. He sold 2 chocolate marble cheesecakes, but we don't know how much they cost. But when we add up all the costs, all the prices, we get $88. That's how much he sold them for. Okay. Similar with Norikai, he sold 5 French silk cheesecakes, but I have to multiply those 5 cheesecakes by the cost of each cheesecake, which I don't know. I add that to 10 chocolate marble cheesecakes times their cost, which I also don't know. But when I add those numbers together, I'd get 125. Okay, so you can go ahead and solve this now. Solve it with elimination. That's probably the best way to go. And show your work as you go. All right, the boat problem, the hardest problems on the worksheet from this week. Okay, here's what you need to know: D equals st. Distance equals speed times time. It will not tell you that in the problem. That's just something that it's going to assume that you know, that you understand. Okay, if you think about it, it kind of makes sense. Let's say you're going 50 miles an hour. That's a speed. And you travel 50 miles an hour for 3 hours. Well, how far are you going to go? What's 3 times 50? It's 150 miles, right? So if you take your speed and you multiply by the time, you're going to get a distance. Okay, so this is just kind of a common fact, common idea that you kind of have to have in the back of your mind, right? Doesn't tell you that, but that's what you need. Okay, now if you read this problem, you'll understand that there's actually 2 trips. There's a trip downstream, and there's a trip back. Okay, so I'm going to have an equation for each one, and what I'm going to do is I'm going to use this as a template for how I need to set up my equation. So I'm going to write D equals S times T. I'm kind of spacing it out because I'm going to replace these things. So I need a distance for downstream and a distance for back. I need a speed for downstream and a speed for back, and I need a time for downstream and a time for back. So those are 2 trips. Okay, the boat traveled 180 miles downstream. That's D for downstream. But then it went back, and it had to go the same distance back. So that means the distance has to be the same for both of them in this case. Okay, equals equals. Right, so we're just using this as a template. Here's the D, here's the D. Okay, next is S. I'm going to skip that for now. Let's go to time. So the time for the downstream trip was 9, and the time for the back trip took 45. Okay, question. Why did it take so much longer to get back? It has to do with this idea of downstream and current. Okay, if you got a river and the water is moving this way, and your boat, let's see how good of a boat I can draw. I don't know, something like this. Let's say this is your motor. Your boat is going in the same direction. The pushing of the water and the boat together are going to make you go faster. You're actually going faster than when you go back. So there's the speed that the boat can go by itself, and then there's the current speed of the water. And if you're going downstream, they're working together. So speed actually gets broken up into two pieces because there's two different kinds of speeds we're talking about. We're talking about the speed of the boat and the speed of the current. Downstream, like I said, they're working together, right? B plus C. Upstream, so turn the boat around. Now the boat's going this way. Again, testing the drawing skills. It's not very good. Here's your little motor. Okay. Now the boat's going this direction, but the current is working against him. And so you actually have to find the difference between the boat speed and the current speed, because the water is going to be flowing backwards while the boat's trying to go upstream. So here we have B minus, oh, sorry, not W. B minus C, excuse me, B minus C. The boat speed minus the current speed. So S is broken up into the B and the C. That's why I have little arrows here. Okay, so notice I got distance equals speed times time. Distance equals speed times time. Okay, now I just got to solve it. If you ignore the 9 and the 45 for a second, this looks like a pretty easy elimination problem. Okay, but we do have that 9 and 45, and remember this is a multiply, right? Multiply by time. So there's a couple ways to do this. You could distribute the 9 through. You'd get 180 equals 9b plus 9c. And you get 180 equals 45b minus 45c. But that's actually more work than you need to do, because you would have to multiply one of the equations again to get the elimination happening. It's much easier in this scenario to divide the top equation by 9 on both sides. That's going to get this guy canceling, and then that's going to give you 20 over here. So 20 equals b plus c. The boat speed plus the current is 20 miles an hour. Okay? Similarly, on the bottom equation, if I just divide both sides by 45, I get that happening. The 45's canceling. We just got to find out what 80 divided by 180, excuse me, divided by 45 is. Looks like it's 4. Okay, so 4 miles an hour is the boat speed minus the current. So when they're working together, downstream, the boat and the current together is 20 miles an hour. When it's going upstream, the boat minus the current speed is 4 miles an hour. But if you notice, this is now set up for elimination. It looks really good. So 20 plus 4 is 24. B plus B is 2B. And then C and negative C eliminate, right? Cancel out. Divide both sides by 2. So that means the boat can go 12 miles an hour if the water's not moving. So that's called the speed of the boat in still water. If the water wasn't moving at all, this is the boat's top speed. Okay? Now we also want to find the current speed, so I can take this and plug it into either of these two. I could also plug it into these two, but these have less going on. So let's pick one of these. So 20 miles an hour is the speed when you have the boat speed, 12 miles an hour, added to the current speed, the speed of the water. So if I just subtract 12 from both sides, I get 8 equals C. Right? So the boat is going 12 miles an hour, the current is going 8 miles an hour. So boat speed, 12 miles per hour, speed of the current, 8 miles per hour. Right? If you add them together, you get 20. If you subtract them, you get 4. There you go. Okay, so it is a little tricky to set up, but the ones that I've given you are all very similar in their setup, just to give you guys some experience. But this is kind of the key. All right, one more. So we got Mia setting up a community garden in her neighborhood. She wants to put a fence around the garden to keep out animals. She has 96 feet of fencing material to use. If the width of the garden is 3 times the length and Mia used all 96 feet of the fencing, find the width and length of the garden. All right. Now probably what I should have put here, I didn't put this, but hopefully from context you guys can pick it up. I didn't put that the garden was rectangular. I should have probably included that detail, but if you didn't get that, there you go. So we're using a rectangle here, and we got length and width. So let's call this guy length and this guy width. But if that's the case, then this measurement that we're calling L is the same as this measurement. That would also be L. And the width on the bottom would also match the width on the top. Okay, so this is all what we call inference. We're making inferences. We're reading between the lines. It doesn't say anything, about setting up this. It doesn't ask you to do it, but this is the information that we know. Okay, we also know that we want to use all 96 feet of fencing. So there's an equation here for perimeter. Okay, perimeter is this distance around the outside of this rectangle. If we do L plus W plus L plus W, that's called the perimeter. And we want it to be 96 feet because we want to use all 96 feet. So the first equation is 2W plus 2L equals 96. Okay? There's two of them because here's an L and an L, and here's a W and a W, right? I have to add these two together, I have to add these two together. Okay, and we're going to get 96. So that's the first equation. The other equation is actually a relationship equation because it tells us how the width is related to the length. The width of the garden is 3 times the length. Width is 3 times the length. Right? W equals 3L. So those are my two equations. Okay. If you look at these equations, you might notice that, hey, there's a variable solved for it. There's a variable solved for already. It's already by itself. Okay. So what I would do is I would replace W with this stuff in equation 1. So let's rewrite equation 1. 2 times W. Okay, not going to use W. We're going to put 3L instead. Plus 2L equals 96. Oops, sorry. That's getting cut off. Okay, so 2 times 3 is 6. So this is actually 6L plus 2L equals 96. Or 8L is equal to 96 when we combine like terms. So if I want just L, I got to divide by 8. Okay, 96 divided by 8 is 12. L equals 12. So that means this is 12 and this is 12. Okay, well, we want the length and the width, right? Well, I could take this L and I could plug it in here and I could find W from that. But this equation already has W by itself, so this is actually the one I want to use. Either one will work. This is going to be easier to use though. Okay, so the width is equal to 3 times the length. But now I know the length is 12, so the width is equal to 3 times 12, which is 36. Okay, so if you wanted to double check, you can do 12 plus 36 plus 12 plus 36. That better give you 96. Pretty sure it does. Let's double check. Okay, it looks good to me. And we just want to write our final answer in context of the original problem. So length is equal to, that was 12 feet, and then width is equal to 36 feet. So I'm using the units that they gave me, which was in feet. I'm going back and writing length and width. Remember, the original problem, they didn't give you variables. They give you length and width. We're the ones that picked L and W. So we don't want to put L equals and W equals because there was never an L and W to begin with. That's something that we assigned. So we're going to finish it off with the answer in context. Okay? All right. I hope that helps. That should help you get you ready for your test, which is on Friday if you are an 8A cohort. If you are a B cohort, it's going to be on Monday. So make sure you go through that. I would practice if you have, if you're struggling with one of these, I would practice. Do another one. Go back and look at your old worksheet, the other worksheet that had questions on them. Set them up again. Erase it and start over. Go back to your old homework assignments from last week if you need to for some of these other ones. Look through your notes. You got the answer key right here. Some of the explanation questions aren't included because that's for you to write. But most of the solutions are here. Keep in mind some of these are no solution or infinitely many solution. Okay, so just use all the skills that we've been talking about to make sure you do well in this test. And I hope you guys do really well. Thanks.